Great work for making it this far. In this section, you're going to have a go at creating a very basic recommendation engine. One user enjoyed the film Gravity, and they want to see a list of recommended movies based on this preference. They want to know, when someone likes Gravity, what else do they tend to like? This is a bit more challenging and will need you to put together everything you've learned so far. To help you along, I've broken this process down into 4 steps. Try and complete each step before you move on to the next one. If you complete all 4, you should get somewhere close to a working solution. We will go through the solution afterwards. So have a go and let's see what films we can recommend to this user. Now I'm going to recommend that you watch this video once through with me just explaining it so you can see what I'm doing. Then feel free to go back and write your query alongside me, but I do think it will help you to follow along first. Step 1 was to match the node for the movie called Gravity and find all users that rated it. That's easy enough, so I'm just going to paste that query in here. We match movie node and restrict the title to Gravity with that property condition, and we find all the users that rated that movie. We've returned both M and U. Now I have used a direction here on the relationship. You don't necessarily need to. And I can run that to return my 29 users that have rated the movie Gravity. So these are the users' opinions who we're essentially going to use in this recommendations model. To find out firstly if they even liked Gravity, and if they did, what other movies did they like? So the second step is to find out if they even liked the film Gravity. So let's add a condition for that, where r.rating, which is the property of that relationship, is greater or equal than 4. So now we can see that we've reduced the number of users down to 16. Only 16 of the original users rated Gravity 4 or higher. So this is the subset of users whose opinions we will use to find other movies. And so the next question is, what other movies did these users rate highly? We can extend the pattern that we have in our match statement. At the moment we have users that rated Gravity, but let's also return in the same query their other ratings. So we need a second relationship, and this one I'm going to give a different alias. We'll call this one rec for recommendations. Again, the type is rated, and that should be connected to other movie nodes. And actually this isn't quite correct because we've already used the alias M over here to refer to the Gravity movie node. So if we use M again over here, that's what we're going to return. So let's use the alias M_rec this time. We need to add these movie recommendation nodes to our output. So let's return M_rec. And we also said that we wanted any movie recommendations to only be those that were themselves rated 4 or higher. So the user's rating of these recommendations happens here in this relationship. So it's that we want to add to their condition. And rec.rating is greater than or equal to 4. Now if you run this query, you'll get something that looks like this. And it appears like we've got one user and roughly 300 movies. But the key here is that not all returned nodes are being shown. The graph is far, far bigger than just this. As we know, we should have 16 users and all of their recommendations. But it takes more power to return all these nodes, so the default is set to 300. You can change this option in the settings down in the bottom left. So I'm going to change that to 1000. Depending on your machine, this may make it run very slow. So by all means, just watch what happens on mine, as really the eventual result we're after will be a table. I'm only using this visual graph to show you what the query is doing. So with 1000 nodes, if I rerun the same query and change the appearance of those user nodes, we can see far more of the graph, but we're still not showing all of it. We can see 8 user nodes, and around each one, we can see the movies they've watched with a rating greater than or equal to 4. And obviously the thing that ties them all together at the very least is the fact that they've all watched the movie Gravity. Let's just have a look back at the query to make sure we understand what's going on. In this case, I think of the users as really central to the query. We're looking for users who rated the movie Gravity, and where that rating was greater than or equal to 4. In addition, we want to return any other movies that they rated, and where those other ratings were also greater than or equal to 4. In our return statement, we return the users, the Gravity movie, and all of the other recommendations. And that's what's led us to this chart. In the next video, we'll look at part 4, where we'll turn this into a list of recommended movies with the average user rating and the count of those ratings too. And so the final step is to return our recommendations as a list. The first thing the list should contain is the movie recommendation title. Movie recommendations are represented by this node on the end. So we want m_rec.title. We also want the average user rating for those recommendations. And that happens in this relationship. So we want the average of rec, and we want to take the rating property from it. Let's return that as average rating. And finally, we want to know the count of those ratings. Obviously, it's far better if 16 of these users have given that recommendation rather than just 1. So let's return the count of rec as reviews. And finally, I want to order the results by the number of reviews descending. And there we have a list of basic recommendations. Of the users who rated Gravity highly, we have 11 reviews saying that they also enjoyed Inception. So that seems like the best bet for the next movie. Looking further down the list, we've got some obvious classics that many people rate highly, like Forrest Gump, but it's pretty cool to see that most of the recommendations here are following the same sort of genre. They're all sci-fi or thrillers, and I'm pretty happy with that result. This was designed as a more challenging exercise to put together all the pieces that you've learned so far. Don't worry if you didn't get it first time. Perhaps take a few moments to go back through the other examples and give it a fresh look tomorrow. What is true is this is a completely different way of thinking about queries, relationships, and databases, so it will take a little time. I'll see you in the next chapter where we can tackle some more graph queries.